Hey, this is Mr. Barr, and this is the pretest for Pythagorean Theorem. Alright, so I have the hypotenuse, but I'm missing a leg, so this is going to be a square, square, subtract, because I'm trying to find a smaller side. So square, square, subtract. That gave me a 64. Take the square root of it, brings it down to an 8. There we go. This time we're trying to find the big side, the hypotenuse. So it's going to be a square, square, add. Square, square, add the numbers to 625, which isn't the length. It's obviously too big. Take the square root of that, takes me down to a 25. Here's a Pythagorean theorem again. This is just a wedge, so I'm going to take it from a three-dimensional shape and I'll turn it into a two-dimensional shape. There it is. So I'm looking for a leg, so it's going to be a square, square, subtract. So square, square, subtract gives me a 9. Square root of 9 is 3. Piece of wood is leaning, so here's the wood. So this is the wood, it's leaning against the wall. And I'm looking for the height of the wall right there. So I'm looking for a short leg, so it's a square, square, subtract. So square, square, subtract takes me to square root of 55, which is 7.4. Notice that it talks about rounding. See, square root of 55. So 7.4, yep, the rounding's good. Is this a right triangle? Well, if I go a squared plus b squared equals c squared, if I go leg squared equals hypotenuse squared, then it works. So I did that. I did 8 squared plus 12 squared equals 15 squared. 8 squared, 12 squared, 15 squared. I got 208 equals 225, which is false. It doesn't work. So it is not a right triangle. Why? Because 8 squared plus 12 squared does not equal 15 squared. Find the distance between the 2 points. What I did is I graphed it. You could use graph paper. So I graphed it and turned it into a right triangle. So I have 7 squared plus 10 squared will be the square root of that will be the hypotenuse. So 7 squared, where am I? 7 squared plus 10 squared gives me 149. Square root of 149 is 12.2. So that was my answer right there, 12.2. This one, I want to find the distance between A and B. So I'm looking at this right here, those 2 points. So I took that little piece and brought it over here as a triangle. So this is A, B, and it says that each square is 1,000. So I went to thousands, 3,000, and 4,000. Then I used the Pythagorean theorem. 4,000 squared plus 3,000 squared is 25 million. Square root of 25 million is 5,000. So that's my answer. Let's see. Here's a triangle. Can I use the Pythagorean theorem? Well, right away I look at that 92 degrees. No, I can't use it. So, yes, Mr. Barr, he can use it. No. Yes, Mr. Barr is correct. No. No, Mr. Barr is wrong. The Pythagorean theorem can only be used with right angles. And that is not a right angle. No, Mr. Barr is wrong. The Pythagorean theorem can only be used when the hypotenuse is known. No. As long as I have a hypotenuse and a leg, or 2 legs, I'm good enough. There we go. So I'm finding the distance between the whiteboard and the door. Whiteboard and the door. I turned it into a right triangle. I counted my rise and my run. Not my rise, my legs. So I had a 3 and a 10. So 3 squared plus 10 squared, 9 plus 100. Square root of 109 takes me to a 10.4. Cool. Thank you for watching. Pretest Pythagorean.